Alright guys, so we're going to do section 218 today. It's the second part of rational functions. So we're going to be looking at horizontal asymptotes. We spent the whole last lesson talking about vertical. So how do you find a horizontal? So that's what we're going to go through today. We're still going to be looking at vertical asymptotes and domain and range all along. We're just now adding in that horizontal part. Alright, so remember at any time you're going to want to pause these videos so you can write along with me. Something I like to do is watch the full example, then rewind it and write it down in pieces, but it's up to you, however you learn best. So here we have g of x. It says 1 over x minus 1 plus 2. So vertical asymptotes are what we learned yesterday, and it was where does the function become undefined? So what you should have remembered from the previous lesson is that you set the denominator equal to 0. So x minus 1 equals 0, because that's going to give me that undefined value, creating the vertical asymptote. Add 1, my vertical asymptote is x equals 1. Alright, so we've got that. Horizontal asymptote. If I wasn't sure, I could absolutely go and graph this on Desmos or something and kind of see what it looks like. So what we can do here is I'm going to go ahead and tell you that it is y equals 2. Now where do you notice a 2 in this equation? Here, right? So that is going to be a relationship there when you have that constant, right, being added completely outside of that rational expression. So that constant is not in the fraction. So you'll see that. So think about polynomial functions. We learned that the constant was the y-intercept, right? Well, now it's that y value that ends up being our horizontal asymptote. Alright, so let's go ahead and graph this. So if I remember correctly from yesterday, vertical asymptotes go through the x-axis at a number. So we're going to draw that dotted line going through x at the value 1. So there is our VA, and then our horizontal asymptote goes to the y-axis at 2. Alright. And that is our HA, horizontal asymptote. Alright, so sort of going off of what we did yesterday, we're just going to draw these curves in here. So these curves, if you have a horizontal and a vertical asymptote, fall in those corners, I guess, of the horizontal and vertical asymptote, as long as there's not any weird negatives or anything. But for the time being, I would have you graph this on Desmos and kind of verify that you're drawing it correctly. Alright, so now let's talk about domain. Domain is all x values, right? X values. So if we're looking at our x-axis, right, so I'm just kind of scanning across this and saying, where does this function exist? Well, I've got all these numbers here on the x-axis that have a point somewhere on this green curve right up here. And then I've got values on this side of the x-axis with points on this other green curve. The only place I don't have an ordered pair for is the x value 1. So your domain is going to go from, so remember negative infinity is over here, positive infinity is over here. We're going to go from negative infinity up to positive 1, right? So that's this section right here. And then u, which kind of, it means union or and. So that's why you see that there. 1 to infinity. So there's a relationship here we want to start picking up on. It's this x value here. Notice how it's right here. because this is a vertical asymptote, the function is not defined at x equals 1, which means it's not in the domain. So you're always going to see the relationship between the vertical asymptote and the domain. So there is a relationship here. So you do want to pick up on that. Make a note for yourself for sure about that. All right, clean this up real quick. All right. So now for range, we're going to look at y values. So for range, that is where does the y-axis, y values have a point on the curve? They have all of them except all the way up to 2, because 2 is where this dotted line is, which means the function doesn't actually exist there. So we're going to write it similarly. So remember, negative infinity is down here, positive infinity is up here. Negative infinity all the way up to 2, union 2 all the way up to positive infinity. Where's this relationship? Well, we've got our y value of 2 for our horizontal asymptote. Notice that that is where this function skips over in this notation. That is a relationship you're always going to see. So you want to make a note for yourself about that as well. So these will also always have, so all of the asymptotes have an effect on domain and range. All right, example 2. So something different going on here. We're going to learn a lot from this example, so make sure you replay it a couple times and take some really good notes. So, what do we know about vertical asymptotes? From yesterday, we learned that these come from the value that makes the denominator 0. So if I need to show some work, I can go and take that denominator and set it equal to 0. Subtract 3, and we're going to get x equals negative 3. Notice every time you have a vertical asymptote, it's an x value where that function does not exist. All right, so zeros, or x-intercepts, right, or roots. We remember all those words. We haven't talked about x-intercepts and where they come from in these functions, but I'm going to teach you that right now. So x-intercepts come from taking the numerator and setting it equal to 0. So if I've got this polynomial function set equal to 0, how do I solve that? Well, I do know how to factor this part, right? So let's come over here and factor it. It's a quadratic trinomial with a leading coefficient of 1, so it's going to be really easy to factor. So we're going to have numbers that multiply to 6 and add to 7. All right, so 2 and 3, 1 and 6. Clearly it's 1 and 6. Oops, 6. All right, so then I'm going to factor this, so it's going to be x plus 1, x plus 6 equals 0. So remember, it's been a minute since we've done this, but when you have your factors and they're set equal to 0, to solve it, you set each individual factor equal to 0, and you sometimes get more than one answer. So if I was to subtract 1 here and subtract 6 here, that's going to give me x equals, from this one, negative 1, and x equals negative 6 from this one. So I have two x-intercepts here. Two x-intercepts here. Let me get this. There we go. All right, so that's what that is. All right, now let's go ahead and graph what we know. We've got this vertical asymptote at negative 3 going through the x-axis. So we'll label that our VA, vertical asymptote. And then we're going to put our zeros. So our zeros are at x equals negative 1, so we have an x-intercept at negative 1, and we have an x-intercept at negative 6. So still haven't told you quite the trick for horizontal asymptotes, so I'm a little unsure. So what I'm going to do is I'm going to go and I'm going to graph this on Desmos and see if I kind of can guess where that horizontal asymptote is. So I'm going to show you. So I went on Desmos and I graphed this. Let's see if I can make this larger for you guys. So there you can see that this is this crazy little curve. We've got our asymptote at -3. That's kind of nice. You can kind of see that going through there. It's visually kind of makes sense. You can see how this curve is going to get really close on this side and really close on this side, but never touch. Here's that x-intercepts that we found, -1 and -6, so that's nice. Doesn't really seem like we're going to have a horizontal asymptote. So remember, asymptotes are values where this function won't exist. So if I draw any kind of horizontal line right now, it's going to touch the graph. So maybe I don't have one, which is definitely possible. So let's go up here. And basically, we just visually figured out that there is none. There is no, I should say, no horizontal asymptote. So we're going to learn that that can happen. So we're going to draw our graph the best we can now. I'm going to look at this picture and cheat a little bit because it's a little funky curve going on. So it's like we've got something kind of happening like this. Right there. There we go. And then we've got something like this on this side. So, very interesting curves, but both curves are needed to make this function. All right, so let's do our domain. So, domain, all possible x values. Ask yourself, which asymptote affects domain? The vertical one, the one that has an x value. Think about that. You can make it easy for yourself. X value, domain. All right, so that means we're going to have an issue at -3. So we're going to write our domain. So think about going from -infinity on your x-axis all the way to +infinity. And it's like we have to jump over -3. So -infinity all the way up to -3. And then we're also going to add in -3 all the way to infinity. All right, now let's do our range. Did we have an asymptote that affected the range? No, because the horizontal asymptote is the one that affects the range because it's always y equals a number. But in this case, this function, something interesting happened. We don't have one. So then let's look at what that looks like visually. If we are looking at our y-axis, right here, I never have to jump over a value. At any point, even at 6, there's an ordered pair for every y value on this function. So the entire y-axis, is covered, where we can move off of that y-axis and find some ordered pair that has this y value. So that means our range is all real numbers. But we write that in our notation that we've been using as -infinity all the way up to +infinity. Remember, this is not an ordered pair. This is representing an interval or a set of numbers that the range exists and a set of numbers that the domain exists. So that's the full example. So make sure you pause and get all these notes written down. All right, 2 quick reminders to have in your notes before we move to horizontal asymptotes. Your zeros come from your numerator. You can see me doing that back in example 2 right here. Okay, zeros will come from the numerator. So set the numerator equal to 0 to get zeros or x-intercepts. Have that clearly stated in your notes. Vertical asymptote, real simple, always comes from setting the denominator equal to 0. And that's going to give you those vertical asymptotes. I will say, you're always going to have at least one vertical asymptote. You could have more than one. But for rational functions, you'll always have, let's maybe go ahead and write that, at least one vertical asymptote. You could have more. All right, so let's actually go into some explanation on vertical asymptotes. So we know that this is a rational function. It's comprised of a polynomial in the numerator and a polynomial in the denominator. So you put those two together and divide them, you've got yourself a rational function. Boom. All right, so we've got some scenarios here. We have, if you have a higher degree, so we're going to be looking at exponents in your denominator, so in the bottom, immediately your horizontal asymptote is y equals 0. No questions asked. That's always how it's going to work. If you have a higher degree in the numerator, you have no asymptote. Well, we've actually seen this example. Let's go back to that for a second. What is your degree in the numerator here? 2, right? Looking at that. What's your degree in the denominator here? 1. So where is your degree higher? On top. So I have no asymptote for the horizontal one, right? So I'm only focused on horizontal for the moment. So just kind of showing you that example 2 kind of gives you that example. All right, what if your degrees are the same? You've got degree 2 over degree 2. Well, then you're going to divide the leading coefficients to get that value, okay? So get this chart copied and have these rules written out for yourself. Once you practice them a couple times, they get really easy, but you need to have the chart and reference it every time you're using it when you're first learning this information. All right, so pause and make sure you got all that copied down. So now, example 3, what are the horizontal asymptotes? So we're only going to spend time on example 3 focusing on this, the new piece of information. The last 2 examples I spent time doing vertical asymptotes and zeros and all that stuff, but I want to just take a moment and focus on this new piece of information. So, what are the horizontal asymptotes? Well, from the last slide, I just explained that we need to look at the degrees. So what is the degree? Let's look at A first, right here. What is the degree of the numerator? It's 2. What is the degree of the denominator? 0. That's a constant right here. So constants always have a degree of 0. All right, so we have a higher degree, and I recommend writing all this out, the first few examples. Higher degree in the numerator. So let's go back to our chart and figure out what that is. Higher degree in the numerator, there's no asymptote. So we have no HA. That is the answer. Like there is not a horizontal asymptote at all for that function. All right, so now let's go to example B. What is your degree in the numerator? Degree is the highest exponent. Well, it's 3. What's your degree in the denominator? Highest exponent. It's 3. So let's go back to our chart and say, hey, what do we do when our degrees are the same? Degrees are equal right here, the last one. It says divide the leading coefficient from the numerator and the denominator. So my leading coefficient here is 8. What's my leading coefficient here? 2. So my horizontal asymptote is y equals 4. So remember, y for your horizontal asymptote. So if you imagine that graph, we're going to have a horizontal line going through the y-axis at 4. So that's where that horizontal asymptote would be. Just want to show you that. All right. If you're feeling good about this and using that chart, I recommend pausing the video and trying the next two on your own and seeing how you do. I'm going to keep on going though. So my degree here is 1. My degree here is 5. I have a higher degree in the denominator. So let's go back to our chart and see what that says. Higher degree in the denominator immediately reverts to y equals 0. So we do have one. Our HA, our horizontal asymptote, is y equals 0, always for this scenario. All right, last one. D, we've got a degree here of 1 and a degree here of 1. All right, so our degrees are the same. They are equal. So let's go see what that relationship was. Degrees are equal, so we're going to divide our leading coefficients. So what's this leading coefficient? 4. What's this leading coefficient? 1. So my horizontal asymptote is at y equals 4. It's a coincidence that B and D have the same horizontal asymptote. It doesn't always end up being 4. It's just how it worked out. All right, example 4. So we're really going to go through everything all at once, and then that's going to be our last one for this section. All right, let's slow down and say, okay, vertical asymptote. What did I write down? What did I need to remember this comes from? It always comes from the denominator, set equal to 0. So I'm going to see this, and I'm going to go, wait a second, I know how to factor this. So we're going to factor it, because we can't solve it until we factor it. This is a difference of perfect squares, which factors into x plus 3, x minus 3. All right. Now when we have two factors set equal to 0, we set each one separately into to 0, and get two answers in this case. So this one's going to give me -3, and this one's going to give me +3. If I think about how that solving looks. So I've got two vertical asymptotes. So let's go ahead and put those on the graph. So if you'll remember on one of those previous slides, I said every rational function will always have a will always have a vertical asymptote, but it also could have more than one. But it'll always have at least one. So obviously something cool is going to happen on this graph. All right, let's think back to zeros. What did I say the zeros always come from? Setting the numerator equal to 0. So we're going to do that. 3x squared plus x equals 0. Can I factor this? Heck yes, I've got a GCF. So let's take out our GCF. It is an x. So if I divide out an x here, I'm going to be left with 3x plus 1. If I'm not sure if I did that right, I want to imagine distributing this x back, and I should get this initial expression back. Okay? All right. Yes, this is a factor. Yes, this is a factor. Set each one equal to 0, and that's going to give you your x-intercepts. Well, this kind of already just generated the answer, right? Going here, and then this one's here. We're going to minus 1 real quick. And get 3x equals -1, divide by 3. So my two x-intercepts here, so that gives me x equals -1/3, are 0, or my two zeros or my x-intercepts are 0 and -1/3. All right, next up is our horizontal asymptote. So let's do that. All right, so this comes down to degrees. What's the degree of the numerator? What's the degree of the denominator? And then we make a choice. The degree of the numerator is 2. The degree of the denominator is 2. So that means the degrees are the same. That's when we divide the leading coefficients. So my leading coefficient on this one is 3, and my leading coefficient on this one is 1. So we've got 3 over 1. So horizontal asymptotes are always y equals a number. So this is going to be y equals 3. So let's go ahead and throw that on our graph. We're going to go through the y-axis at 3. Let's go ahead and put our x-intercepts on here. We've got one at 0 and at -1/3, which is going to be really close to each other. So we're going to do our best to draw that okay. All right, domain and range. Well, even though I haven't drawn my curves, I still have a really good idea of domain and range, because domain and range are only affected by their vertical or horizontal asymptotes. All right, so let's go over this domain and range right here. So domain, all x values, right? So I'm going to look at this x-axis, and I don't have a problem until right here, all the way to right here. So it's going to be a very interesting looking domain. It's definitely one of the more involved ones. So we start at negative infinity, all right? And we work our way all the way up to negative 3. And then we got to skip over negative 3. Alright, and then we go from negative 3 to 3. And then we got to skip over 3 and go all the way over to positive infinity. So that's the most involved you'll ever see your domain. Alright, range. Let's look at that. So, y values. Don't have any problems except for positive 3. So if I start down at negative infinity, work my way all the way up to positive 3, skip over 3, and finish off at positive infinity. So now you're probably like, alright, cool, but how the heck do we draw this crazy looking function? Well, I'm going to show you that right now. And what I did is I grabbed on Desmos if I'm unsure of where to put the curves. So here's my Desmos picture, and you can see how we've got our little, this would be at negative 3, our two vertical asymptotes right here, and then we can see our horizontal one at 3 here. So now it's kind of cool because the graph also verifies that I probably did my asymptotes right, because you can kind of see how these graphs will approach those lines but never quite touch them, because remember that's what an asymptote is, horizontal or vertical. It is that place where the function tries to get really close to that number but never actually hits it. So now I'm going to go up here, I'm going to sketch those graphs in as best I can. And then we've got this. Alright, and that's it.